This video is part of a series of videos on DXi replication. In this video, I'm going to provide an overview of the DXi replication feature. I'll cover the purpose of replication, an overview of how replication works, and the requirements for configuring replication. I will also provide an overview of the two types of replication, continuous namespace and file cartridge based. This video is designed to provide an overview of replication information. The other videos in this series contain demonstrations on how to configure replication. Data replication is the process of copying deduplicated data from one DXi system to another for purposes of disaster recovery. In the event of a disaster, such as a flood, in which the original data is lost, you can quickly recover the replicated data from the remote system, allowing your business to resume normal operations. Once the original system is available again, you can restore or fill back all data to its original location. Replication occurs on the DXi systems in two stages. First, unique blocks of data are sent from the source DXi to the target DXi. Then, metadata is sent from the source DXi system to the target DXi system, allowing the target DXi to reflect the current data state of the NAS share or VTL partition on the source DXi. To configure replication, you need two DXi systems, one configured as the replication source and the other configured as the replication target. In addition, deduplication must be enabled on the VTL partition and NAS share configured for replication. This optimizes the speed of replication since the data will be reduced in size. As previously mentioned, there are two types of replication: continuous namespace replication and file cartridge-based replication. Let's start with continuous namespace replication. The continuous part of continuous namespace replicates deduplicated unique data. During a backup, data is ingested, deduplicated, and continuously replicated in the background. The deduplicated blocks of any new data written to a VTL partition or NAS share with replication enabled is automatically replicated. The namespace part of continuous namespace sends the metadata associated with the data based on files present at the start of each replication. Metadata is what's used to retrieve data and recreate the files in a NAS share or cartridges in a VTL partition. Namespace replication starts when you manually start replication or when the replication process is scheduled to begin. It creates a point-in-time snapshot from which you can recover your VTL partition or NAS share. So why would you want to configure continuous namespace replication? Mainly for disaster recovery purposes. If something happens to your source DXi system, the point-in-time snapshots that you create with continuous namespace replication allow you to recover a NAS share or VTL partition to a previous state. After your source DXi system is back up and running, you can fail back a snapshot to your source DXi system and recover the data. Now let's go over file cartridge-based replication. File and file cartridge-based applies to NAS shares, and cartridge applies to VTL partitions. With file cartridge-based replication, replication and recovery occur automatically after a cartridge is unmounted in a VTL partition, or after a file is closed in a CIF share, or after a certain period of time in an NFS share. The key is that this occurs automatically, meaning no manual intervention or scheduling is needed. If files are deleted on the source DXi system, they will automatically be removed on the target DXi system as well. After automatic recovery, the data is immediately available for use on the target DXi system. This brings the source DXi system and target DXi system into sync. You can also manually synchronize data between the source DXi system and target DXi system if needed. Why would you want to manually synchronize data if this is supposed to happen automatically? Well, if a file cartridge-based replication job fails, or if file cartridge-based replication is disabled for a period of time, manually synchronizing data brings the source DXi system and target DXi system into agreement. So why would you configure file cartridge-based replication? Because the data from your source DXi is automatically replicated and recovered, it is always in sync and available for use on the target DXi. You don't have to take the extra step of recovering your data from a snapshot. In this video, I provided an overview of the DXi replication feature. The remaining videos in this series provide demonstrations on how to configure each type of replication. continuous namespace replication, and file cartridge-based replication.